In this video, let's find out the technical rate of substitution for a CES production function. Assume that we have a CES production function y is equal to, the output is equal to some function of labor and capital. And the form of CES production function is equal to a L to the power of rho plus bk to the power of rho and whole to the power of 1 over rho. So let's find out the technical rate of substitution for this CES production function. In order to make it simple, assume that this A is equal to B, A is equal to B, and equal to 1. Then this production function will change to this one, y is equal to L to the power of rho, k to the power of rho, whole to the power of 1 over rho. So now, let's find out the technical rate of substitution for this simplified version of CES production function. And we have the formula for the technical rate of substitution, which is technical rate of substitution of labor for capital is equal to negative marginal product of labor divided by marginal product of capital is equal to, we know that marginal product of labor is equal to the partial derivative of this production function with respect to L, and marginal product of capital is equal to the partial derivative of this output, or this our y with respect to capital. So now, in order to find out the partial derivative of y with respect to L and the partial derivative of y with respect to k, we need to use the partial derivative rule for generalized power function rule. Generalized power function rule, which is one of the rules for partial derivatives. If we have assumed that if we have z is equal to g of x of y, g of x and y whole to the power of n, then if we want to find out the partial derivative of this z with respect to x, it will be equal to, we first need to take the derivative of the power function, which is equal to n, this n, multiplied by gxy to the power of n minus 1, then multiplied by the partial derivative of this x, which is the inside, this g, which is inside function with respect to x. So now we will apply this generalized power function rule in this case. So now it's equal to partial derivative of y with respect to L. We use that generalized power function rule, which will be equal to 1 over rho. In this case, our n, that n is equal to 1 over rho. This one multiplied by L to the power of rho plus k to the power of rho whole to the power of 1 over rho minus 1 multiplied by, so now we need to take the inside derivative, the derivative of this function with respect to L. So now it will become to rho multiplied by L to the power of rho minus 1, to the power of rho minus 1. The same things we all need to do for the derivative of y with respect to k, which is equal to this power function, 1 over rho multiplied by L to the power of rho plus k to the power of rho and whole to the power of 1 over rho minus 1 multiplied by, so now the partial derivative of this inside function with respect to k. So there's no k, only we have k here. So then it will become equal to rho multiplied by k to the power of rho minus 1. K to the power of rho minus 1. So we can make it more simple by cancelling some equal factors. 1 over rho with 1 over rho will be cancelled out. This row with this row will be cancelled out. L to the power of rho plus k to the power of rho whole to the power of 1 over rho minus 1. This one with this one will cancel out. The only things that will remain here, it will be equal to minus L to the power of rho minus 1 divided by K to the power of rho minus 1. And finally, we can write down that one. Technical rate of substitution of L for K is equal to minus L over K to the power of rho minus 1. Or in another term, we can write down minus K divided by L to the power of 1 minus rho. To the power of 1 minus rho. So this is the final step, the technical rate of substitution of L for K in this simplified version of CES production function will be equal to minus L over K to the power of rho minus 1 is equal to minus, in another term, K over L to the power of 1 minus rho. And mostly we are using the absolute value of the technical rate of substitution. In terms of absolute value, then the TRS in terms of absolute value will become equal to K divided by L to the power of 1 minus rho. This negative sign will be removed when we use the absolute value. So then, finally, the technical rate of substitution for a CES production function is equal to either this term or this term, anyone you're comfortable with. Thank you for watching. See you next time, and hope to subscribe my YouTube channel and press the like button, share your comment and any question you have. See you.